Hey, Bear Scammon here at the Eugene Science Center. We've got a classic experiment for you today. It's the potato battery. But before we get into anything potato related, I do want to talk a little bit about electricity, how it works, and what a battery is and what it does. So what I've got here is a standard AA battery. It's something that you might use in a flashlight or a small electronic device. And what it is, it's an electrical cell, which means it has electrical potential, which is a fancy way of saying that it has electrons on one part of the battery that really would like to get to the other side of the battery. But it needs a bridge, like a wire, so the electrons can move outside of the battery and come to the other side. Now, while they're traveling, if there is something interrupting its path, like a light bulb, it'll flow through the light bulb first and then return back to the battery. And as those electrons are flowing, they light up the light. So different batteries have different amounts of electricity that they can produce. And we usually measure that in voltage. Now, voltage is a measure of electrical flow that tells you how much electricity is pushing through the wire. Now, we can measure that with a voltmeter. And what we have here is we got two wires coming off of it, and the black wire goes to the negative end and the red wire goes to the positive end. And you can see on most batteries that there's a little plus sign on the positive end, and sometimes there's a little negative end on the other side, but this battery doesn't have that in particular. Now, if I hook it up to this battery, most AA's are about 1.5 volts. So let's see how this battery measures up. And look at that. We're coming up with 1.4, which is really close to the 1.5 that we'd be expecting. Now, we can increase the amount of volts that we get out of batteries by lining them up in series, which is what I've got right here. And that's where you line the positive end right up with the negative end of another battery. And so I've got the positive end to the negative end and the positive end to the negative end of these three batteries. And that should increase the voltage quite substantially. So the three batteries are connected via Play-Doh, which is actually electrically conductive. So all of these are connected very well. Now, if I put the negative end next to the negative side of my battery series and the positive end next to the positive end, we should see, once again, we've got a 3.3 volt battery series here. So that's a little bit more than twice what we get from a single battery. Now, it could hypothetically get all the way up to 4.5 volts if we had a perfect series and all these batteries were 100% fresh. It's a little unclear about which is just battery fatigue and which is the conductive material that we are using. But we can harness this battery series to power a couple things. I've got an LED light and I've got a little buzzer. So let's see what we've got. So I'm going to put a red wire with the positive end because that's pretty classically what you'll get in most electrical work. Red is positive and black is negative. Now, as I'm hooking this up, let's see what we've got. So red to positive, black to negative, and we get that wonderful green LED light coming on right there. Excellent. And let's try our buzzer. Now, our buzzer also has the red for positive, black for negative, so we're going to match those up. So positive is connected. You'll notice it's not working right now because we do need a complete circuit, a circle. So we've got one end coming in here. It's not working. We need to complete the circle. Oh, our black side came out. Completing the circle, completing the circuit. And we got that buzzer going off. Excellent. Okay, so it's potato time. And you're going to need to gather your supplies. What you'll need is a couple potatoes. They can be russets, they can be red, they can be golden potatoes. Really, any type of potato will do just fine. You can even use lemons if you'd like. They don't work quite as well, but they're pretty good. You're also going to need a source of zinc metal. So galvanized nails are a classic. Also, zinc washers are what I'm going to be using today. They work great. You can pick those up at your local hardware store. Also, you're going to need a source of copper. So if you got copper wire at home, maybe it's insulated, all you need to do is strip it off with a wire stripper. Or I also just love these copper washers. You can also use copper pennies as well. Now the big key with both your copper and with your zinc, whatever you're using, is that it's not overly corroded. Now if there's a bunch of rust growing on it, you're going to want to take a little piece of sandpaper and just scrub it off, make it nice and shiny. So you do not need to use a full potato for each potato battery. Pretty much any amount of potato should work pretty well. So I'm going to be cutting my potato in half, and I'm going to be cutting it lengthwise. Now the reason I want to do that is that the zinc and the copper really do very well when they're as far away from each other as possible on the potato. So I'm going to be putting this on my cutting board, and I'm just going to get one big slice through. And now I've got my 2 halves of the potato. This one's a little bit shallower than I'd like. I'd typically do this with a bigger potato, and I'd cut it just slightly more evenly, but it should do just fine. I'm going to put this right on my, my cutting sheet, and I'm going to take 1 zinc washer and 1 copper washer, and I'm just going to push it into my potato. If you find it difficult to put whatever zinc or copper material into your potato, just use a knife and make a little incision, and that will make it a little bit easier to put whatever metals in that you need to put in. So now I've put my zinc in and I've put my copper in, and I do want to make sure that it is got a fair amount of it hanging on the outside. Now the reason for that is that we're going to need to attach wires or alligator clips to these, so you need to have nice nodes that you can clip onto. So now that our potato battery is all set, we should test it. So we're going to bring out our voltmeter, and all you need to do is put the red end on the positive side, which will be our copper node, and the black end on the zinc side, which will be our negative node. And let's see how many volts our potato battery is able to supply. Looks like we got 0.9, so just shy of 1 volt, which is pretty good for one of these. Now if we wanted to get more power out of our potato battery, we would need more potato batteries. Alright, so we've got our potato chain going here, and through all of these 10 potato batteries, it looks like we're coming out with just over 7 volts of electricity. So I'm going to unhook our voltmeter, and we're going to try to light up our LED right here. Now the power does need to go through the LED, so I'm going to be hooking up to the 2 wires that are here in the back. The positive to the positive end and the negative to the negative end, and voila! There we go, we got our beautiful green LED. And we got another thing. Let's see if we can make our little buzzer go. Now our buzzer does need about 3 volts of electricity to run, so we do have a little bit more than it needs, so let's see if it goes through. Alright, hooking negative to negative and positive to positive, and we've got that little buzzer going. Excellent. Now that's all we got for you today, but please go ahead and try making this at home. If you need more power, making more batteries is a great way to do it. What you're going to want to do is you're going to want to hook the negative end of one, the zinc side, to the positive end of a new battery, and chain them up like that, and see what else you can power with your potato batteries. And we'll see you in the next video. Bye-bye.